Hey, this is Don from Padlock Technologies again with another video. Today we're going to talk about seamless/unified MPLS. This is a technique that is usually done in a service provider. You don't really learn this in the CCIE, enterprise, or route and switch for us old guys. I'm going to give you a little bit of theory about it, and in the next video I'm going to create a lab to show you exactly the theory live. So let's start to the whiteboard here or blackboard, and we're gonna just, you know how I do my titles. We'll do seamless/unified MPLS. So what is this? This is pretty much a technique that's going to allow you to have different routing domains for security purposes, but allow you to do MPLS over the top and signal your PE to PE communication via BGP. Basically, I'm going to send a label to my ASBRs, which is going to go over the routing domain. So this is going to be over the top of your individual routing domains and allow you to still send traffic via MPLS. Again, this is a service provider technique. You're really not going to learn this in CCIE, enterprise, infrastructure, or route and switch for, like I said, us old guys. So let's look at it from the overarching. So we are going to have PE1, provider edge 1, provider edge 2. All right. And here we're going to have OSPF1. That's routing domain 1. Then we're going to have, let's say, 4 ASBRs. So ASBR 1, ASBR 2, ASBR 3, SBR 3, and ASBR 4. Okay. And then there, let's say we're going to be running ISIS. So that's routing domain 2. And then over here, we're going to have PE3, PE4. And there, we're going to have OSPF2 as the routing domain. So now, and there is no redistribution whatsoever. So whatever is known in OSPF1 is not known to ISIS or OSPF2. Okay. So the key here, though, is we're going to run a couple commands here. So command number 1 is BGP, obviously. This is going to be one big ASN. So let's say this is going to be BGP ASN. I'm just going to use a non-public one. Let's say this is 65005. Okay. So everybody's going to be using this ASN. And the only one things that are going to be doing BGP is here, this router, these ASBRs, and this ASBR. So now you can see where unified or seamless is coming from, because even though I'm in 3 separate routing domains, from a BGP perspective, we're all in the same ASN, right? Now, on the ASBRs, there's a couple commands we need to run. One of them is going to be a command called next hop self all. The all is very important because that means I'm going to change the next hop for eBGP and iBGP. If you know BGP, when you do that next hop self command, it's usually used for eBGP going into iBGP, because if you know BGP, the next hop is not changed when you're doing eBGP, right? That eBGP next hop doesn't change. So when it goes into iBGP, you need to change it to a router that you can get to, or you won't even be able to look at the route, right? The route won't go into the route table. You won't even be able to do best path selection, because the first pre-best path selection is, can you get to the next hop? If you can't get to the next hop, you won't even see it, right? And then the next command is send label. Now the send label command, if you looked at my other video of how can you generate a label, you got LDP, got RSVP for MPLS traffic engineering. You have segment routing, which is a newer technique, and you have BGP, right? Now you usually do this send label command when you're doing like inter AS, option B, stuff like that. because that's a whole different topic. I don't want to get into inter-AS L3 VPNs. That's probably going to be another video later on down the line. But just know when you do the send label command, it creates a label in BGP. It allows BGP to create the label. So this next hop self command and the send label command is going to be on the ASBRs for every neighborship that you're going to build. And then on the PEs, you are only going to do send label. Right? Once you establish the adjacency, you got to make sure you do send label, right? On all of these. Now the send label command, again, is going to allow BGP to create the label. What you're going to do on all your PEs is you're going to advertise a loopback, right? The loopback of the PE, because you need to know how to get to each PE in this setup. Every PE needs to know how to get to every PE via MPLS, but you also need to know it needs to be advertised in the BGP, right? So when you advertise the loopback is going to get sent to the ASBR. ASBR is going to send it with a label, right? So PE is going to send it to the ASBR with a label. ASBR is going to have its own label. Then it's going to send it down to the other PEs with another label from the other ASBR, and ultimately it gets down to the ASBR3 will send its label to PE 3 and 4. Okay. Now from the ASBR perspective, here, this is going to be full mesh IBGP. So this is going to be full mesh IBGP, okay? And going to each PE, these are going to be route reflectors. So the ASBRs are going to be route reflectors to each PE, but ASBR to ASBR is just going to be full mesh IBGP, okay? So that's going to allow you, when you advertise those routes from one end to the other, from a route reflector standpoint, it allows you to send it to other PEs. So that's why you want to make sure you have the ASBRs as route reflectors, and then the PEs are going to be route reflector clients. Ultimately, what this is going to do is this is going to allow full end reachability, no matter what the routing domain is. It's going to allow end-to-end reachability from PE to PE, because the loopbacks are going to be known everywhere, right? Because they're going to get advertised down, and they're going to have an MPLS label. So now when you do MPLS, it knows how to, hey, whatever routes are behind PE3 that gets its own VPN label or whatever, I know how to get to the PE now. I just need to make sure I put the label, make sure all the labels are stacked. And when we see it in the lab, you're going to see the label stack, and you'll see that top label just gets swapped ultimately as it goes through each of these routing domains. So how does it do that? Well, there's one key thing here. The ASBRs have to live in all the routing domains, the loopback, basically. So the ASBR loopback has to exist in OSPF1, ISIS, and then 3 and 4 obviously need to live in OSPF2 and ISIS, right? So now, from a next hop perspective, everybody knows how to get to the ASBRs in its respective routing domain. And then doing this will allow you to reach every domain, no matter what routing domain they're in. You can get to every PE. And that's the benefit of seamless MPLS and unified MPLS. It allows you to just add routing domains in, and then you can keep the security standpoint, because you're not going to know the internal topology information of each routing domain, but you'll know how to get to each PE ultimately, because you're going to let BGP do the overlay over the top, right? So it just allows you to plug in a new routing domain, do BGP, connect to the route reflector client or route reflector, and then know how to get to every route within the domain. Now, you don't need to know the topology information in each routing domain. You just need to know how to get to the PE. And when we get to the video, the lab video, I'm going to show you this entire setup. We're going to do some trace routes so you can see the label stack as it moves through each routing domain. And then ultimately Wireshark it so you can kind of see, like, okay, here's the label, here's the stack. I like to do Wireshark. Look, if you're in this game for a long time, you need to get very familiar with Wireshark, especially from a network perspective, so you can see things, how it works. If you know how it works at them little intricate levels, then when it's time to do like complex routing and stuff like that, it makes it easier, because you know how it works at the, ones and zeros, as I like to call it. But how this moves through end to end is it'll move through, this PE, then you have your internal or intermediate routers in the middle. You'll see the swap going. Then it gets to the ASBR, swaps again, gets to the next ASBR, swaps again, ultimately gets down to PE, right? And ultimately, whatever the intermediate router is in the middle, which is going to be the penultimate router, that's when the PHP process happens, penultimate hot popping process happens. Then it ultimately gets to the PE, which is called the ultimate router. So why would you do this? Again, you can have multiple different routing domains and then have a huge BGP domain over the top. And you don't have to worry about doing redistribution, because when you do mutual redistribution, now you have to worry about route loops and all that good stuff. With this, you can keep all the routing domains separately, still have BGP over the top, and then still seamlessly move MPLS from one domain to the next domain. Hence the name seamless or unified MPLS. So this is Don from Parallel Technologies again. I hope this video was informative. If you got any more questions, put them in the comments. I do look at the comments, so I will answer it. If I do make a video on it, I will reply and say, hey, I'm making a video on this topic. Look out for it. Um, look out for the next lab video. Thank you and have a nice day.